Okay, our first video, we're going to work on adding and subtracting functions. So example 1, how do you define the sum f plus g and the difference f minus g of the function f of x equals 3x plus 4 and g of x equals x squared minus 5x plus 2? Because we're going to have a conversation about domain in all these problems, let's go ahead and define the domain of our f and g functions. From the beginning, we want to recognize if there are any domain restrictions for us to be aware of. So first, let's look at the domain of f of x. So our f function is 3x plus 4. So here's our x. It's being multiplied by a 3 and adding a 4. Is there any number that exists that you cannot multiply with a 3 and add a 4 to that product? And there is not. So we have no restrictions on our domain of f of x, so we're just going to say all real numbers. I'm just going to abbreviate that a little bit. And then how about the domain of g of x? So our g of x function, x squared minus 5x plus 2. Is there any restrictions on this domain? Is there any number that you cannot square, multiply by a negative 5, and then do those operations? And there is not a number. You can square anything, you can multiply anything by 5. So our domain for g of x is also all real numbers. Domain restrictions show up when we have x in the denominator of a fraction. We've seen that before. If you're square rooting a value that has the variable underneath the square root, that would have some domain restrictions. So those are some things that we'll just look out for. But all right, so what is this now? Part A, what is the sum of f of x and g of x? So they're asking us to find f of x plus g of x. So our f of x function is 3x plus 4 plus our g of x function, which is x squared minus 5x plus 2. We're going to find that sum. Now, anytime you're adding and subtracting, it comes down to combining like terms. And then just look to see, is there any distributing to do in front of either of the functions? And there's not. If you're just taking one function and adding another one, we're just adding our like terms. Be sure to always start with the highest exponent. So we have an x squared. There are no other x squared to combine with that. So x squared. Here we have a 3x minus a 5x. So 3x plus negative 5. Or 3 minus 5 is negative 2x. And then we have a positive 4 and a positive 2, so 4 plus 2 is 6. So our function, f of x plus g of x, and you might see this written, another way to write that is f plus g of x. It's another way to show the sum. You could write it this way up here, or you could represent the sum that way, is x squared minus 2x plus 6. And now we need to identify the domain of that sum. So the domain, well, we want to make sure we include any restrictions we may have found in the beginning, which we didn't have any, all real numbers. So then let's look at the sum. Is there anything in here creating a domain restriction? Can you square all your numbers? Can you multiply them all by a negative 2? And you can. So the domain of our sum is also all real numbers. All right, so part B is very similar. Instead of adding, we're going to subtract. And when it's written in sentence form like this, what is the difference of f of x and g of x? That's just going to go right in the order. It's going to be f of x minus g of x. So our f of x function is that 3x plus 4. We're going to subtract g of x, which is x squared minus 5x plus 2. So just be careful that you're subtracting in the proper order. And also be careful anytime you are subtracting. This is where mistakes get made. We are subtracting all of these terms. My advice is to rewrite it and distribute that negative. So the 3x plus 4, nothing changes there. But if we distribute this negative, it's like a negative 1 you're distributing. You get a negative x squared. Distribute the negative to the negative 5x, turns to a positive 5x. And distribute the negative to the 2 is just a minus 2. And now we can find the difference, which we've already taken care of the difference part of it, so just combine like terms. Your highest exponent is the x squared, so we have a negative x squared. Then 3x plus a 5x, those are both positive, so we're going to have plus 8x. And then we have a 4 and a negative 2, so 4 plus a negative 2, or 4 minus 2 is positive 2. So again, we could say f minus g of x is just another notation. Again, you can write it the way we did above, f of x minus g of x, or f minus g of x. And we got negative x squared plus 8x plus 2. And then we want to identify the domain of that difference. So we go back, if you remember, the domain of the original functions were all real numbers. If we had found a restriction in the beginning, we would include that in our domain for our final answer here. And then did we create any new restrictions with the operation of subtraction? And we did not. So our domain remains all real numbers. If you were to write that in interval notation, that would be negative infinity to infinity, just another way that we've seen domain written.